You're welcome to Medical Sciences Made Easy by Naphtali Muhumuza. And in this session, we want to talk about urine formation. We know in the medical field, we use urine to determine or to rule out urinary tract infections, to rule out any issue with the kidney. So we want to see how does the kidney do this work of urine formation. How does urine be formed in the kidney? And the functional unit of the kidney is the nephron. And this nephron, you find one kidney has millions of functional nephron. And these are the functional cells where urine formation occurs. So urine formation begins when blood is being taken up into the kidney, or it is being perfused, whereby blood which is coming passes through the renal artery. And the renal artery joins the afferent arteriole. And this afferent arteriole is wider than the efferent. We see the lumen of the afferent is wider than the efferent arteriole. So afferent is the one that brings in blood into the glomerulus, and efferent is the one that takes it after being filtered. And we are saying that the afferent is wider than the efferent. And as blood coming through the afferent arteriole into the glomerulus, it contains substances like water, electrolytes whereby we have cations and anions like sodium, calcium, potassium, chloride, bicarbonate. All these are chlorides. These are electrolytes. It contains glucose, amino acids, then the waste product of metabolism like creatinine, urea, uric acid, then proteins and blood cells. So this is the blood that is entering via the afferent, containing all these compounds, which we have listed below. So when blood reaches into the glomerulus carrying all these compounds, within the glomerulus is like a sieve, whereby it filters. When blood reaches, it filters only small molecular weight substances. Only smaller molecular weight substances like, so small molecular weight substances are filtered. Small molecular weight substances like electrolytes, like glucose, urea, creatinine, amino acids. Then we have uric acid, water. All these, because they are small in size, they are filtered. And how are they filtered? We are saying that the afferent arteriole being wider than efferent arteriole. This one, together with the proteins and the water in the blood, it creates a net. Hydrostatic pressure. And this net hydrostatic pressure is of 25 millimeters of mercury. But before I go ahead, this urine formation is categorized into 3, whereby we see it happening under ultrafiltration. We see stages like ultrafiltration, then selective reabsorption, and tubular secretion. So these are the three steps involved in urine formation that occurs by, the first one is ultrafiltration, or what you can call simple filtration, followed by selective reabsorption. Why selective reabsorption? Selective reabsorption because we are reabsorbing substances according to the body's need. Then this is called ultra because it is filtration under pressure. Then tubular secretion, these are substances which are secreted via the tubes. As urine is moving, they join from the surrounding capillaries. So these are the three stages involved in urine formation, and we are beginning with ultrafiltration. So we have begun with ultra or simple filtration, and we are saying simple filtration, it occurs in the Bowman's capsule. The whole of this is the Bowman's capsule where ultrafiltration or filtration under pressure occurs. And what creates pressure is that the afferent arteriole being wider than the efferent, it is creating, together with plasma proteins and water being exerted in the blood, it creates a net hydrostatic pressure. This net hydrostatic pressure of 25 is the one that enables filtration of smaller molecular weight substances. So it enables filtration of smaller molecular weight substances like electrolyte, uric acid, glucose, amino acids, water, urea, and creatinine to be absorbed or to pass through the filter to join the glomerular filter. So these ones are found in the glomerular filtrate because they are smaller in size. Then the higher molecular weight substances, higher molecular weight substances like proteins, blood cells, those are platelets, red cells, RBCs, and white BCs. For them having a higher molecular weight, they are greater than 70 daltons. Because they are high, they have a higher molecular weight substances. These filtrate, they are very small, that they cannot allow them to be filtered to join the glomerular filtrate. So these substances like proteins and blood cells are not found in the glomerulus. They are not found in the glomerular filtrate. In the glomerular filtrate. So as the blood comes via the afferent, we see smaller molecular weight substances. These ones, they are filtered and they join what we call the glomerular filtrate. They form part of the glomerular filtrate. Whereas the higher molecular weight substances, which I have listed here, the proteins and blood cells, for them being large in size, they are not filtered, so they continue into the afferent, into the efferent. So we find the proteins here, and blood cells. Then the smaller molecular weight substances, we find them here. The electrolytes, the waste products of metabolism, like urea, uric acid, creatinine, water, and glucose. For them, they form part of the glomerular filtrate. So this is what we can explain under ultrafiltration, or what we call simple filtration. So under ultrafiltration, what the students should know in an exam is that you should mention, tell us that the afferent arteriole being wider than the efferent arteriole, this creates a net hydrostatic pressure together with the water and the plasma proteins in the blood. And this net hydrostatic pressure forces smaller molecular weight substances like these ones to enter into the glomerular filtrate. Whereas the higher molecular weight substances like proteins, blood cells, being large in size, they cannot be filtered. So for them, they continue into the efferent and goes back into the saturation. That's why we don't find blood cells and proteins in a normal blood of a person. So that is ultrafiltration. And this one leads us to the second stage, which is selective reabsorption. And this selective reabsorption, for it, I told you the word selective means that these substances are reabsorbed according to body's need. Whenever the body needs more glucose, it is reabsorbed. When it does not need, it is not reabsorbed. When the body needs more water, it is reabsorbed. That's why we call it selective reabsorption. So, under selective reabsorption, we are going to see in different parts of the nephron about these components of the filtrate. We are going to be reabsorbing them one by one. And we are going to start with the proximal convoluted tubule, whereby in proximal convoluted tubule, we see selective reabsorption of electrolytes. When we talk of electrolytes, we are meaning sodium, we are meaning of chloride and calcium. These ones are electrolytes. Then we have glucose. Then we have amino acids. Amino acids are reabsorbed. Reabsorption, and this reabsorption is by active transport. They are actively reabsorbed. They are actively reabsorbed. So meaning to reabsorb electrolytes, glucose, amino acids, we need energy in the form of ATP. So these ones, for them, they are actively reabsorbed depending on the body's need. When the body does not need them, they are not reabsorbed. And they normally tell us that greater than 70% of glucose is reabsorbed in the proximal ends. And even then there is also, we see reabsorption of water, whereby greater than also 70% of water is also reabsorbed here. Water, urea, for them they are reabsorbed by passive transport. This is passive. Passive transport is the one that enables reabsorption of water and urea. Or sometimes for water you can say by osmosis, but it is a passive transport. It does not require, passive means it does not require energy to be reabsorbed. So this is how it occurs in the PCT, or what we call the proximal convoluted tube, where we see reabsorption. So you tell us whenever you are answering, you must end it by saying, are they actively transported? Show us what are actively transported, and those which are not, which are passively transported back into blood, depending on the body's need. Then from the PCT, the glomerular filtrate continues to descend via the thin descending limb of rope of Henle. And in the descending limb, this descending limb is permeable to water. It has the aquaporins, so it is permeable to water, but impermeable to electrolytes. Impermeable to electrolytes. That is the descending limb. So in the descending limb of rope of Henle, we see only reabsorption of water, majorly reabsorption of water. We see majorly reabsorption of water by osmosis, and then we see this by osmosis. And because for urea it is always smaller in molecular size, it is both secreted and reabsorbed. So we see reabsorption of water by osmosis and urea by passive transport. So for it, urea is passively reabsorbed, whereas water is reabsorbed by osmosis. But we are saying that it is only permeable to water aquaporin, but for urea it is smaller in size, so it freely moves out and freely comes in. That is how urea is. So that is what we talk about under descending limb of loop of Henle. And after seeing what is happening in the descending limb, we are going to see what is happening in the ascending limb. So allow me to create some space here. So we are now going into the ascending limb, and always the ascending limb is thicker than the descending. It is thick. And the opposite is true. We have seen this one is permeable to water, ascending, the descending, but ascending is impermeable to water. We have seen descending is impermeable to electrolytes, but ascending is permeable to electrolytes. So we see the ascending limb, for it is permeable to electrolytes. So we see here reabsorption of electrolyte, that is in the ascending limb. So in ascending limb, the thick ascending, we see reabsorption of electrolytes. Which electrolytes are we talking about? Electrolytes like calcium, potassium, electrolytes like calcium, potassium, chloride, magnesium being reabsorbed by active transport. This one is by active. It requires ATP. It involves energy in form of ATP for you to reabsorb these electrolytes in the thick ascending, because we are seeing the thick ascending is permeable to electrolytes, but impermeable to water. And this is what normally brings the other concept, which we normally say that as the filtrate is moving down, because water we are losing it, the osmolarity keeps reducing. If I'm at 1,000, it goes to 700, it goes to 500, 400. By the time I'm reaching here, it is like at 200. But when you are going back, the osmolarity also starts to increase, because you are not losing water, you are only losing electrolytes. So that is how it happens. Actually, it does not reduce here, it keeps on increasing. Whereby here, if I have 200, it becomes 300, 400, to 1,000. Then when we are going back, it keeps on decreasing. It goes back to 800, 500, to maybe 200, and it goes back. Because that is what we call countercurrent flow, or what you call countercurrent multiplier effect. That because of this being permeable to water and impermeable to electrolytes, as you go down, osmolarity increases. As you are moving up, because you are losing electrolytes without using water, osmolarity also decreases. That is what we call a concept of countercurrent multiplier effect. After leaving the descending limb, that is the loop of Henle, we now go into the distal convoluted tubule. This is the distal convoluted tubule, which is folded, and in the DCT, we see majorly reabsorption under influence of hormones. And the disclaimer is always that if more sodium is needed, because we see more of sodium here, whereby we normally say even if also greater than 70% of sodium is reabsorbed in the PCT. But in case our body needs more sodium, if more sodium is needed, it is reabsorbed under influence of aldosterone hormone. under influence of aldosterone. And this aldosterone hormone is produced from the adrenal cortex. So whenever the body senses there is need for more sodium in the body, it triggers the adrenal cortex to release hormone known as aldosterone. And this aldosterone hormone is the one that makes the cells of the distal to become permeable to sodium, because naturally they are impermeable. So, but when hormone comes and stands there, it makes them to become permeable, and more sodium is reabsorbed under influence of aldosterone hormone. The second one is that if more water is needed, if the body needs more water, it is also reabsorbed back into the body under the influence of ADH, what we call vasopressin. And this vasopressin hormone is produced by the hypothalamus. It is synthesized in the hypothalamus, secreted from the posterior pituitary gland. So it is stored in the posterior pituitary gland. Posterior pituitary gland. So it is this vasopressin hormone that comes and causes the cells of the distal convoluted tubule to become more permeable to water. If more is needed, maybe a day you have not taken water and the body needs more water, so it produces vasopressin hormone, which causes the cells of the distal to become permeable and will absorb more water. That's why you see on a sunny day and a day when you are so busy sweating, you literally not urinate so much because more water is being reabsorbed under the influence of antidiuretic hormone. The last statement is that if more calcium is needed, if more of the calcium is needed also in the body, we see it being reabsorbed under the influence of a hormone, and this hormone is known as parathyroid. Parathyroid hormone, and this parathyroid hormone is produced by the parafollicular cells of the thyroid. We know that the thyroid has follicular and parafollicular. So parafollicular cells of the thyroid gland releases parathyroid hormone, which causes more reabsorption of calcium into the blood. So these are the major points we look at under digital convoluted tubule, under three hormones. Please don't forget these hormones when you're answering in an exam, that we need aldosterone, we need vasopressin, and we need parathyroid. Without them, we cannot reabsorb these compounds back to the body. After knowing that, this glomerular filtrate continues to move, into the collecting duct. Here is the collecting duct, which joins the urinary bladder. So in the collecting duct, we see in the collecting duct, this was ascending in the collecting duct. We see reabsorption. If this collecting duct is also impermeable to water, but if more water is needed, is also reabsorbed. So we see in the collecting duct that if more water is needed by the body, it is reabsorbed. It is reabsorbed under influence of ADH. Still, vasopressin hormone is the one that is making the cells of the collecting duct to become permeable to water. So that when more water is needed, maybe you have not taken any water since morning, you have been maybe vomiting and losing so much water. We see it also ADH coming into play to make more reabsorption of water. And that's why normally we see that animals in the deserts have longer rope of Henle and collecting duct. Why? Because they are to conserve water. So rope of Henle and collecting duct plays a big role in maintaining water in the body. But the major trigger factor is always that when there is increase in hydrogen ion always triggers production of antidiuretic hormone from posterior pituitary gland and causes these cells to become permeable. And this is the end of selective reabsorption. So this is selective reabsorption, whereby selective reabsorption, we have seen what happens in the proximal convoluted tubule, what happens in the descending limb of loop of Henle, what happens in the ascending limb of loop of Henle, what happens in the distal and the collecting duct, whereby this was A, this is B, this is C, this is D, and this is E. The last point under urine formation is tubular secretion, which is tubular secretion. That is process number 3. Is tubular secretion. That much as we are reabsorbing substances back into blood, we also have some substances that are being secreted via the tubes of the nephron. So we are going to see which substances are secreted. And substances like hydrogen ions, substances like potassium, substances like ammonium ions, and substances like drugs like penicillin. Penicillin. So when you are on penicillin drugs, these are secreted via the tubules. So substances like hydrogen ions, potassium ions, ammonium ions, and drugs like penicillin are secreted. And this secretion is seen majorly, they are secreted majorly in the proximal convoluted tubule and the distal convoluted tubule. This is the major sites where these secretions occur. So that is what you discuss under tubular secretion. That as the filtrate is moving via the nephron, there are some more substances that are being added. Not even forgetting our urea, because also urea is secreted. I told you for urea is both secreted and reabsorbed because it is small in size. So these are the substances you mentioned which are secreted, majorly in the PCT and the digital convoluted tube. And that is the end of tubular secretion. Now, the filtrate which is leaving the collecting duct is no longer filtrate, but now it is urine. Now we can comfortably call it urine. And this urine, it is going to move from the collecting duct to the ureter. It joins the ureter, whereby we have the left and the right ureter. They go into the ureters, and this ureter joins this urine into the urinary bladder. So it is taken into the urinary bladder, where it is stored temporarily. It goes into the urinary bladder, where it is stored temporarily, and it is secreted, or it is excreted. It is excreted at intervals via urethra. That's how we excrete this urine. Stored temporarily in the urinary bladder, and it is excreted via urethra. This is the urethra. At intervals. And this is what marks the end of urine formation. So we have seen all the processes of urine formation, where we have seen ultrafiltration, which is filtration under pressure, created by afferent being wider than efferent, and also the plasma proteins and water, which causes the net hydrostatic pressure of 25 millimeters of mercury. And it is this net hydrostatic pressure that forces smaller molecular weight substances like electrolytes, waste products of metabolism, water, to be filtered. Whereas higher molecular or large molecular weight substances like proteins, blood cells, being large in size, they do not pass through the filtrate, so they are not found in the glomerular filtrate. That's why whenever I find blood cells in urine, I find proteins in urine, I worry so much about what is happening on the glomerulus. That is what I worry about. Then we have seen selective reabsorption. Why? Because substances are reabsorbed according to body's need. And we have seen whenever you are discussing about reabsorption, tell us, is it active transport or passive transport? So we have seen active by electrolytes, glucose, and amino acids. Then reabsorption of water is by osmosis, urea by passive transport because it is small in size. We're going into the limb, descending limb, where there is major reabsorption of water because descending limb is permeable to water. Then we went ahead to ascending limb, where we have seen reabsorption is majorly electrolytes because it is permeable to electrolytes but impermeable to water. So we have seen a reabsorption of electrolytes by active transport. Then in the distal convoluted tubule, we have put a disclaimer that if more water is needed, a vasopressin hormone comes and makes them to become permeable. If more sodium is needed, aldosterone hormone from adrenal cortex. And if more calcium is needed in the body, then parathyroid hormone also comes in to cause more reabsorption of calcium in the body. Then it continues in the collecting duct, where we have seen that if more water is needed still, it is reabsorbed under influence of antidiuretic hormone. And lastly, we have seen on tubular secretion, under which tubular secretion we see only reabsorption, secretion of hydrogen ions, potassium ions, ammonium ions, penicillins, and urea being secreted to join the filtrate and finally form urine. Thank you so much for listening to this urine formation. We are always at your service, and always remember to subscribe. If you haven't subscribed, always remember, like the video and share your comments. We meet.